I, we are going to do problems in the heading dimensional formula and vectors. Problems in dimension. Basically, we have three uses in dimension method. First one, to check the correctness of the given equation, we are using dimensional method. Second, to convert from one system of unit to another system of unit. And next, third, to derive the equation for physical quantities. So we will see few problems in each of the three uses. First one, to check the correctness of the given equation. V is equal to U plus AT. We will take up this equation. Using dimensional method, whether it is correct or not, we can find out. Dimensionally, V is the velocity. Dimensional formula LT power minus 1. U, that is also velocity. LT power minus 1. A, that is called acceleration. LT power minus 2 into time is T. That is T power 1. So LT power minus 1, LT power minus 1, LT power minus 1. Left hand side LT power minus 1, right hand side also LT power minus 1. So dimensionally correct. That's all. We are not checking mathematically. We are checking only dimension. Second, V square is equal to U square plus 2AS. Dimensionally, velocity left hand side LT power minus 1 the whole square, U LT power minus 1 the whole square. There is no dimensional formula for constants. So ignore 2. A is acceleration, S is displacement. So L square T power minus 2, L square T power minus 2 plus L square T power minus 2. Left hand side, right hand side, same dimensional formula. Not necessarily everywhere, left hand side and right hand side should have same dimensions. Sometimes it may differ. Say for example, half mv square is equal to mgh square. Check dimensionally. M dimensional formula L, V velocity LT power minus 1 the whole square. Right hand side M, capital M. G, M means capital M. G, acceleration due to gravity. LT power minus 2 the whole LT power minus 2 H square L square. So I can write M L square T power minus 2. Right hand side M L cube T power minus 2. Left hand side and right hand side, they are not equal. Dimensionally, it is not correct. Okay. So this is checking the correctness of the given equation. Next. to derive the equation for physical quantities. Sometimes exactly we don't know what is the actual formula, but what are the quantities it depends upon, slightly we can understand. So based on that, it is possible to calculate the exact formula by dimensional method. For that, we can give some examples. Time period of a simple pendulum. When simple pendulum is suspended, you oscillate it. After some time, it comes to rest. So the time taken for one oscillation, that is called time period. So that time period T, according to the problem, it is proportional to three factors. Number one, mass of the bob which is suspended. And number two, the length L, length of the pendulum. And number three, the acceleration due to gravity, G. So I can write T is equal to a constant K, M power X, L power Y, G power Z. Write the quantities on the right hand side, power X, power Y, power Z. Because exactly we don't know what is mass value, L value, G value in this particular problem. So we have to calculate by equating dimensional formula on both LHS and RHS. Calculate X, Y, Z. So dimensionally, left hand side time period. So dimensional formula is T. No mass, no length, but we have T. M, M power X, L, L power Y. G is called acceleration. Acceleration due to gravity, LT power minus 2 power Z. So I can write M power 0, L power 0, T power 1 is equal to M power X, L power Y, L power Z, L power Y plus Z, T power minus 2Z, T power minus 2Z. Equating the powers. So you have to bring left hand side and right hand side same MLT form. Then only you can equate. Equating the powers, both the sides. X is equal to 0. Y plus Z is equal to 0. Minus 2Z is equal to 1. So Z is equal to minus half. When you say X is equal to 0 and Z is equal to minus half, what will happen here? Substitute Y minus half is equal to 0, Y is equal to half. So X, Y, Z we have calculated. Any problem, constant value will be given. If it is not given, write K itself. If it is given, substitute. Otherwise, write K itself. Here, K is equal to 2 pi. Given. So substitute in equation 1. T is equal to K. K is 2 pi. M power X m power x is 0. L power y. What is L power y? L power half. G power z. G power minus half. So t is equal to 2 pi L power half by G power half. 2 pi root of L. This is time period equation for a simple pendulum. So the time period T depends on three factors: mass of the bob, length of the pendulum, acceleration due to gravity. Using dimensional method, derive an expression for time period. This is the question. Like that, two more questions we will do. Assuming the frequency of a vibrating string may depend upon applied force F, length L, and mass per unit length small m. Prove that frequency nu is equal to k into 1 by L root of T by m, or nu proportional to 1 by L root of F by m. Frequency of a stretched string proportional to given three factors. Number one, force. Number two, length. And number three, mass per unit length. So force, mass per unit length, and length of the string. Okay. So using this, we will do force, length L, mass per unit length M. You can straight away proceed the dimensional formula, or you can put nu is equal to constant k, F power x, L power y, M power z. Dimensional formula. Nu frequency T power minus 1. F force ML T power minus 2 power x. L power y. Next, M power z. M is mass per unit length. It is not the mass. Mass per unit length. So mass by length. Mass by length is M L power minus 1 power z. So left hand side M power 0, L power 0, T power minus 1 is equal to right hand side M power x, M power z, M power x plus z, L power x, L power y, L power minus z, x plus y minus z, T power minus 2x, x plus z equating the powers is 0. X plus y minus z is equal to 0. Minus 2x is equal to minus 1. So from this I can write x is equal to half. Substitute this value here. Therefore, half plus z is equal to 0. Z is equal to minus half. So x value, z value you have calculated. Next we have to calculate y. Substitute these two in second equation. X half plus y minus z. Z is already one minus, so it is plus of is equal to 0. Y plus 1 is equal to 0. Y is equal to minus. So x, y, z, all the three we have calculated. Substitute in this equation. 1 nu is equal to k into f power x, f power half, L power y, L power minus 1, m power z, z is minus half, k, power minus will go to denominator as plus. So k by L, f power half, this m power minus half will go as m power half in denominator. And one more thing, power half means it is square root. So I can write this as root of f by m. K given means you write the value of k. Actually, k is half here, 1 by 2. So this will become 1 by 2L root of f by m. That f is nothing but tension in the string. Root of t by m also we can write. But t means it will be confused with the time period. So they have given f, tension. 1 by L root of 1 by 2L root of f by m actual formula. K not given means k by L root of f by m. This is dimensional method. Second concept, to derive the equation for physical quantities. Third, third use to convert from one system of unit into another. CGS to MKS, MKS to CGS, FPS system we have, foot pound per second. So that conversion from one system of unit to another system of unit, dimensional method we can use. So for that also we will do two problems. First, if the value of universal gravitational constant in SI unit is 6.6 into 10 power minus 11 Newton meter square kilogram power minus 2, then find its value in CGS system. SI to CGS we have to calculate. Given G is equal to 6.62 into 10 power minus 11 Newton meter square kilogram power minus 2. Convert into CGS system. Any question given like this, first you should know what is the dimensional formula of the given quantity. Sometimes universal gravitational constant, exactly physical quantity they will give, or from the unit you have to find out what is the dimensional formula. We will do another example, you will understand better. Dimensional formula of G. F is equal to G m1 m2 by R square. This is Newton's law of gravitation. So G dimensional formula we know, we have to calculate Fr square. Fr square. What is F? Force. Dimensional formula mLT power minus 2 into R square, that is L square, by m1 m2, mass into mass, m square. Cancel. What will you get? M power minus 1 L cube T power minus 2. So this is the dimensional formula for gravitational constant. M power minus 1 L cube T power minus 2. So directly you can put x is equal to minus 1, y is equal to 3, z is equal to minus 2. What quantity to be calculated? GCGS. What quantity is given? GSI. M given means M1, L1, T1. To be calculated M2, L2, T2. Power X, power Y, power Z. So I can write GCGS. Take this to the right hand side. GSI, what is the value? 6.62 10 power minus 11 into M1 by M2 power X, L1 by L2 power Y, T1 by T2 power Z. Okay. (6.62) into 10 power minus 11. M1. This is the mass in SI unit. SI unit mass is 1 kilogram. CGS unit mass is 1 gram. Power X. What is X? Minus 1. Next. L1 by L2. L1 in SI unit. 1 meter. This is 1 centimeter. Power Y. What is Y? 3. T1 by T2 power Z. T1 in seconds. T2, that is also in seconds. 1 second by 1 second. Power is Z. What is Z? Minus 2. So, GCGS is equal to 6.62 10 power minus 11. You have to convert kilogram to gram. CGS unit only you have to convert. So, 1 kilogram, 1000 gram is 1 kilogram. So, 1 gram is 1 by 1000 of a kilogram. 1 by 1000 of a kilogram. Power minus 1. 1 meter, 1 centimeter. 100 centimeter is 1 meter. So 1 centimeter is 1 by 100 of a meter. Power Y, that is power 3. 1 by 1, 1 power minus 2, 1. Okay. Now GCGS is equal to 6.62 10 power minus 11. Kilogram cancelled. This 1000 will go to numerator. 1000 is 10 power 3 power minus 1. Meter cancelled. 100 will go to numerator. Numerator means it will become 10 power 2 power 3. 6.62 10 power minus 11. 10 power minus 3. 10 power 2 power 3 is 10 power 6. 10 power minus 3 minus 11 minus 14. This is 10 power 6. 10 power minus 8. 6.62 into 10 power minus 8 is the final answer for gravitational constant in CGS system of unit. In CGS system. That is, instead of force, dyne. Meter square, centimeter square. Kilogram power minus 2. Gram power minus 2. So this is the conversion from one system of unit to another system of unit. One more problem also we can try. Convert 5 by 18 meter per second square into kilogram per hour. Meter per second. Convert 5 by 18 meter per second into kilogram per hour. 5 by 18 meter per second into kilometer per hour. Next, convert 5 by 18 meter per second into kilometer per hour. 5 by 18 meter per second into kilometer per hour. Meter per second is a unit of velocity or speed. Unit of meter per second. Unit meter per second is for speed or velocity. Dimensional formula. First step. Velocity or speed is displacement or distance by time. LT power minus 1. So, m power 0, L power 1, T power minus 1. X is equal to 0, Y is equal to 1, Z is equal to minus 1. Okay. What is to be calculated? Velocity, kilometer per hour to be calculated. Velocity meter per second is given. M1 by M2 power X, L1 by L2 power Y, T1 by T2 power Z. Velocity meter per second is 5 by 18. M1 by M2. M1 is meter per second. Actually, velocity or speed is independent of mass. So this term will never arise at all. Dash. Mass M1 and M2 are called corresponding mass. Here there is no question of mass. So dash. Power 0. M1 by M2 power 0. Even if we have something, power 0. L1 by L2 meter per second, 1 meter. This is 1 kilometer. Power Y. What is Y? 1. Next. T1 by T2. T1 is in seconds. 1 second. This is 1 hour. Power. What is the power? Z minus 1. So I can write V kilometer per hour is equal to 5 by 18. 1 meter, 1 kilometer. See, you have to convert in terms of kilometer per hour. So change this meter into kilometer. 1000 meter is 1 kilometer. So 1 meter is 1 by 1000 of a kilometer. 1 by 1000 of a kilometer divided by 1 kilometer. Power 1. 1 second by 1 hour. You have to write this answer in terms of kilometer per hour. So naturally, this only you have to convert. 3600 second is 1 hour. So 1 second is equal to 1 by 3600 of an hour by hour. Power minus 1. Kilometer cancels. Hour get cancelled. So you will get 5 by 18. This is 1 by 1000. 1000 is 1000 will come in denominator. 10 power 3. You are going to take it to numerator. So it will become 10 power minus 3. 1 by 3600. Power minus 1. Invert. 3600 by 1. 18 and 36. 2 times. 5 into 2 into 100 divided by 10 power minus 3 as 1000. 1 0 get cancelled. Another 0 is also cancelled. So I can write 5 into 2, 10. 10 by 10. 1 kilometer per hour. 5 by 18 meter per second is equal to 1 kilometer per hour. So any vehicle is moving at a speed of 5 by 18 kilometer per hour, meter per second. It will move as 1 kilometer per hour in the other system. From CGS, from MKS, we are converting to CGS system or slightly higher. It is not the normal. Kilometer per hour, it is moving. But to write in the problem, we need the answer in terms of meter per second. Okay. So these are the basic problems in dimensional analysis. So next we will go for problems in vectors. Problems in vectors. First problem. The position vectors of the particle has length 1 meter and makes 30° with x-axis. What are the length of the x and y components of the position vector? First problem. Components of a vector. Generally, the length of the vector they have given us 1 meter. It is making an angle 30° with x-axis. Component of vector we have studied. Any number or any value you are getting, say in this case it is for length. You can represent this L in terms of x-axis and L in terms of y-axis. Lx, Ly. Horizontal component L cos theta, vertical component L sin theta. Suppose if you are taking theta here, this will become horizontal, this will become vertical. So the cos component, sin component depends upon where you are taking theta. Lx is equal to L cos theta. Our aim is to calculate Lx. Lx is equal to L cos theta. What is L? 1 meter. Cos 30. What is cos 30? Root 3 by 2. Cos 30, cos 45, cos 60. Root 3 by 2. 1 by root 2. 1 by 2. So this is root 3 by 2 meters. Ly is L sin theta 1 into sin 30 degree. Sin 30 is what, man? Half. 1 by 2, 1 by root 2, root 3 by 2. 30, sin 45, sin 60. So half. 0.5 meters. Correct? Second problem. We'll go. A particle has its position moved from R1 to R2. R1 is 3i plus 4j. R2 is I plus 2j. Calculate the displacement vector and draw R1, R2 and delta R in a two-dimensional Cartesian coordinate system. R1, R2. This is I cap, j cap. This is only delta R. R2 minus R1. You have to calculate the displacement vector delta R. Therefore, delta R is equal to R2 minus R1. What are the data given? R2 as I plus 2j and R1 as 3i plus 4j. I plus 2j minus 3i plus 4j. I minus 3i minus 2i. 2j minus 4j minus 2j. Therefore, delta R is equal to I minus 3i is minus 2i minus 4j 2 minus 4j. 2 minus 4j means minus 2. So minus 2 we can take it out. Minus 2 into I plus j. This is a position vector. If R1 having some value and R2 some value given, we can calculate the difference between the two. Third problem. Calculate the average velocity of the particle whose position vector changes from R1 to R2 in time 5 seconds. R1 value is 5i plus 6j. R2 value 2i plus 3j. You have to calculate average velocity. Velocity is rate of change of displacement. V is equal to dr vector by dt. Rate of change of displacement. What are the displacements given? R1 and R2. That is R2 minus R1 by dt. R2 value 2i plus 3j minus, what is R1 value? 5i plus 6j. V vector is equal to 2i minus 5i minus 3i. 3j minus 6j minus 3j. Minus 3 common, I plus j. This is velocity by time. What is time? 5 seconds. Yes, it is 5 seconds. By 5. By minus 3 by 5 into I cap plus j cap. This is a velocity for the given R1 and R2 values in a time t. Fourth problem. Convert the vector R is equal to 3i plus 2j into a unit vector. R is equal to 3i plus 2j. We have to convert into unit vector. R cap. R cap means R vector by modulus of R. What is R vector? 3i plus 2j by modulus root of 3 square plus 2 square. 3i plus 2j. 9 plus 4. Root 13. Simple. This is for the problem. Fifth one. What are the resultants of the vector product of two given vectors A and B? You have to calculate the vector product of two vectors A and B. A and B given. A vector, B vector. Two vectors given, you have to calculate the vector product. What is A? 4i minus 2j plus k. B vector 5i plus 3j minus 4k. 5i plus 3j minus 4k. Given, you have to calculate vector product. Vector product means A cross B. Modulus, not modulus, this is determinant form. I, J, K. What is A value? 4 minus 2 plus 1. Here 5 plus 3 minus 4. Whenever you are multiplying like this, inside the bracket, determination form, this column, that particular column and that particular row you omit, remaining you cross multiply. I want to calculate for I. So leave this column, this row. Totally get. I cap multiply -2 -4 is 8 -3 minus j I minus j plus k, that is the concept. Minus j into leave that column and that row. 4 into -4 -16 -5. So I can write phi I -16 -5 is -21 plus 21. Pi I plus 21j is the answer for vector product of two vectors A and B. Next. Sixth one. The resultant of two vectors A and B is perpendicular to vector A and its magnitude is equal to half the magnitude of vector B. Then angle between A and B is given. Resultant of two vectors A and B is perpendicular to vector A. This is vector A and this is vector B. This is resultant R. These two are perpendicular given. This is theta. This is theta. This is B. This is. What is the angle between these two? That's what you have to calculate. Here, angle between A and B. That's what you have to calculate, ma. Take it as theta dash. Theta plus 90. So this theta only you have to calculate now. Given R is equal to half of B, B by 2. This is given in the problem itself. Here, calculate cos theta. Opposite side by hypotenuse. Opposite side by hypotenuse is sin theta. Cos theta you want to calculate. Adjacent side by hypotenuse. Adjacent side is what, ma? R. Opposite of 90 only hypotenuse. R by B. But cos theta is equal to R is B by 2. B by 2 by B. B cancel the half. Cos theta is equal to half. Then what is theta? Therefore, theta is equal to 60 degrees. Implies theta dash is equal to 90 plus theta. 90 plus 60. Correct? So these are the few problems in vector analysis. Next class will continue. Thank you.